Hello and welcome to a new software product presentation. My name is Christine, and today we're diving deep into the world of automation technology and looking at how the skilled workers of the future are trained. It's about virtual mechatronic learning factories and digital twins in the lab and in the training room. And for that, we have a very special software highlight with us, PLC Lab 3D Studio. To bring this closer to us, I've brought in the best possible support directly from the developers at MHJ Software. Nicholas is joining us. Hello, Nicholas. Nice to have you here.
Hello. Yes, thank you for the invitation. I'm happy to be able to present our new product.
Great. Nicholas, let's jump right into the topic. For all our listeners who don't know PLC Lab 3D Studio yet, please catch us up. What kind of software is it, and what was it designed for?
With pleasure. At its core, PLC Lab 3D Studio is a tool specially developed for training and further education in the field of automation technology and Industry 4.0. Imagine you are in a vocational school, a university, or in corporate training. Instead of being dependent on expensive and often rigid hardware models, you can create and simulate complete virtual learning factories directly on your PC with our software. You can use it to recreate typical learning scenarios from Industry 4.0, from material detection, processing, and quality assurance to sorting parts and storing them in a virtual high bay warehouse. The big advantage is flexibility. Learners can experiment, write programs, make mistakes, and see the consequences directly on the 3D model without any danger to themselves or expensive machines.
So it shifts the trial and error from the real machine to a safe virtual environment. The centerpiece for this is the 3D model in Blender. You told me that you designed it to be as simple as possible. How exactly does that work? Do I, as a teacher or trainee, now have to become a 3D designer?
No, absolutely not. That was very important to us. That's why we've developed two things that make getting started much easier. First, the MHJ Asset Library. This is a toolkit with ready-made 3D objects like conveyor belts, cylinders, sensors, or buttons. Everything's included. The trick is, these objects already come with their basic function, or skill. A skill is, so to speak, the ability or role of an object in the model. For example, transporting, detecting, or moving. With this, you can also easily assign a skill to your own objects with a click, for example, a lamp or a capacitive sensor. You make the detailed settings later in PLC Lab 3D Studio. In Blender, it's just about the basic assignment.
Okay, I understand. The asset library for a quick start with ready-made parts, and the plugin to bring your own objects to life. That sounds really well thought out. Let's run through this with a concrete example. How about a typical sorting task?
That's a perfect idea. That's a classic practical example that covers many core competencies. Let's imagine the following. We build a small system with 3 conveyor belts arranged at a 90-degree angle to each other, forming an L shape. Various cubes are placed on the first belt, cubes of metal, as well as white and black plastic cubes. These are then transferred to the second belt. At the end of this second belt, we position our sensors to analyze the cubes, and based on what the sensors detect, the cubes are then sorted into different chutes with the help of pneumatic cylinders. This is an ideal learning scenario to program sensors, actuators, and sequence control. Let's build this step by step.
Good. Then show us your screen. I'm excited. What are we seeing here? Can you give us an overview?
Gladly, this is Blender with a new project. On the left side is the MHJ Asset Library. In the middle is the layout window where we will build the system. On the far right is a so-called outliner with the project tree and the object settings. To the left of that, the plugin for the 3D Studio is visible.
At first glance, that looks quite complicated.
Yes, with powerful software tools, the first impression is always overwhelming. But you have to remember that you only need a fraction of the many tools in Blender to build a 3D system.
Yes, I can well imagine. I don't use every available feature in Word either.
Exactly. For all viewers who want to replicate the system, here are a few more details. The Blender project should be set to millimeters. Furthermore, the Move gizmo should be enabled. To ensure the object colors are displayed, you should set the viewport shading to Material Preview. We'll now start by inserting a table to place the conveyor belts on. In the assets, I'll search for the table, click on it, and drag it into the layout window. And if you look at the object name, you'll see that even the table already has a skill. The collider skill makes the table a solid body, which means that a workpiece, in our case a cube, won't fall through the tabletop.
Okay, that's a simple skill. It's probably used often, right?
Yes, it's by far the most used skill, as you can imagine. Without solid bodies, nothing would work. And now we'll add all the components we need for our desired system. So a conveyor belt, a 90-degree conveyor belt for the corner, a chute, the cylinder to push a cube onto the chute, and a sensor for material detection.
But we still need another belt and more chutes and sensors, don't we?
Yes, good thinking. Objects that we need multiple times, we simply create through duplicates. It's just faster.
Copy and paste?
Exactly. First, we form the L shape of the conveyor belts. For that, I'll create a duplicate of the conveyor belt. I select the black frame of the belt and press this button from the plugin to select all parts of the belt. Now I can duplicate it with Shift and D. Now the duplicated belt is rotated by 90 degrees, specifically around the Z axis. I press the R key, followed by the Z key, enter the number 90, and confirm with the return key. And now we switch to the top view, zoom in a bit to arrange the objects better. The 90-degree belt also needs to be rotated. Since we are in the top view, we automatically rotate around the Z-axis. So we select the frame and rotate with R and entering 90, confirming again with the return key. And now we can arrange the three belts correctly. It's important to ensure the conveying direction is correct. The conveying direction is visualized by the black triangles on the belt. We now move the 90-degree belt to the left of the conveyor belt and the remaining belt directly under the 90-degree belt.
What are those displays with the symbolic mouse in the bottom left?
Oh, right. I almost forgot about those. They show live which mouse buttons and key combinations I'm currently using.
Ah, well, that's great. And here I thought I had developed clairvoyant abilities. So, for everyone who's diligently taking notes, you can put your pens down. There's an overlay.
Yes, my bad. I should have said that right away. I guess you could call it developer's blindness. I see the display every day and completely forgot that it's not immediately obvious to others. All right, let's continue. With the chute, we'll first position the chute on the far right side of the belt, then select all its components via the button in the plugin and duplicate it twice. Now just arrange both duplicates, and then we can check off the three chutes.
Yes, the copying is very fast. Great. What's next?
Now we'll focus on the cylinders that push the cubes onto the chute. We'll place the first cylinder in the middle of the chute on the far right, but first it needs to be rotated 180 degrees. Now we move it to the chute. There, and now duplicate it twice again. We'll align the first duplicate right away and the second one as well.
Now for the sensors, right?
Exactly. We already have one sensor in the scene. We'll place it next to the cylinder on the far right for now, and also check the height alignment. To align the sensor precisely, we'll move the cube to the same position, then we can align the sensor optimally. By the way, the green cube below the sensor housing is the actual sensor that can detect the cube. The cylindrical structure above it is actually just decoration, but it's absolutely essential to immediately recognize the object's function. The yellow ring on the sensor housing is a lamp that will connect to the same input, so we can see if the sensor triggers or not.
Yeah, that's practical. Makes sense.
Now the sensor is almost aligned.
However, the green sensor trigger needs to be moved a bit more towards the center of the cylinder rod so that it triggers at the right moment. To do this, we simply rotate the upper mounting of the cylinder by 20 degrees.
It's good that you have all the freedom in Blender to change the object.
Very well observed. In a rigid modular system, that would probably not have been possible at all. So I think this is fine now. I'll make the duplicates now.
That already looks pretty much finished. Is anything missing?
Yes, the work pieces we want to sort. We still need to create the different cubes made of metal and plastic with the two colors black and white. We can create all of these from the existing cube. First, the 3 different cubes that we place on the table, and then we'll use a so-called creator to define where the cubes should appear.
What's this about the creator? Can you explain that in more detail?
Yes, of course. I'll continue building in the background and explain it to you briefly. Well, in a typical automation system, something is usually being processed. Whether it's a product or a bottling plant, something is being produced or processed in some way. This part has to be introduced into the system somehow, and that's the job of the creator. It creates objects.
What objects can the creator create?
Basically, any 3D object. You have to arrange the objects it's supposed to create as child objects of the creator. Then the creator knows what to produce. And the position of the creator is also the starting position of the children. So the cubes and the creator are placed. I'll now select all 3 cubes and mark the creator as the parent object. Now, if I move the creator, the children should move with it. That seems to work.
Yes, I see it the same way.
Now we need to give the creator object the creator ability because currently it still has the abilities from the toolkit, namely player and collider. The player skill, by the way, is the necessary skill for the workpiece that can be transported. We select the creator, first remove all skills with the plugin, and then add the creator skill.
Are we done now, or?
Yes, in Blender, we've now prepared the 3D model. In the next step, the skills need to be configured within PLC Lab 3D Studio.
What exactly needs to be done now?
Well, the sensors still need to be connected to the inputs of the PLC and the actuators to the outputs of the PLC. It also needs to be said how fast and how far the cylinders extend. And the sensors also need to be configured, i.e. whether they are inductive, capacitive, or optic.
Now it's getting complicated again, isn't it?
It sounds complex, but it's usually not as complex as building the model itself. We'll now create a project directory on the desktop and save the Blender file in it. Then we'll export it as an FBX file, which PLC Lab Studio 3D can open. Everything else will be done in PLC Lab Studio 3D.
That means the real magic happens in the studio now?
Yes, exactly, if you want to call it that.
Show us how to proceed in the 3D Studio.
Yes, gladly. I've started the 3D Studio, and now we'll load the generated FBX file from the project directory. Our system is now displayed. And first, we'll adjust the camera position so we have a good overview of the system. We'll then save the camera position using the keys Shift and 1. We'll also set a second camera position where we have a better view of the sensors. We'll save the new position with Shift and 2.
And how do I switch the camera position now?
Simply by pressing the 1 or 2 key.
All right, I thought so. And how is this window structured? Explain to us what we're seeing.
On the left side is the tag window with all current inputs and outputs. During the simulation, you can observe the status here. We'll change the content shortly and enter the inputs and outputs we need for our sorting system. Up here in the toolbar, we can select the target device. The target device contains the program that controls the sorting system. This program is normally written by the learner.
We'll select the C# script device from the list here because I have prepared a script for our sorting system. In the next step, I'll add the inputs and outputs for our system. This is a prerequisite for configuring the skills. With this button, I can open and edit the current list. I select all lines, delete them, and insert my prepared list. You can see here that each line contains the address, the symbol, the data type, and the comment. Now I just have to save, and all symbols are defined.
And where does this list come from?
In this case, I simply created the list in a text editor. If you have a TIA portal project, you can also import the list via an export file. Since the symbols have changed, I'll open the project again, and then I can start with the skill configuration.
Where do we start with the skill configuration now?
The order doesn't matter. We'll start with the cubes that are generated by the creator, then the cylinders, and finally the sensors.
Okay, I'll let you get on with it.
Yes, gladly. And if you have any questions, just interrupt me. The skill configuration is now done as follows. All 3D objects that have been assigned a skill in the Blender file can now be selected. With the Control key pressed, I move the mouse pointer over the objects and see that they light up if they have a skill. If I want to configure a skill now, I hold the Control key and click with the left mouse button. Now on the left side, the so-called Skill Manager appears. Here you can select the skills of an object to edit them afterwards. On the right side, the Settings window appears with all the settings for the selected skill. Let's start with the workpieces. After the mouse click, the workpiece is filtered in the Skill Manager, and you can see here that there are 2 skills available, Player and Collider. You can specifically click on the skill you want to configure. That's why we're clicking on the Collider skill here. In the Collider skill, I can now specify that only an inductive sensor should detect the workpiece. We don't need to change anything else here. In a similar way, the plastic cubes now need to be configured. With the Control key held down, I click on the white cube and set the sensor triggering to optical. And now the black cube with the sensor triggering set to capacitive.
And the sensors are now configured to match the cubes, right?
Correct. We'll go to camera setting number 2 and configure the first sensor to inductive. For the sensors, we also need to set the correct input. For this sensor, B0 must be entered, and for the others, B1 and B2. We set the second sensor to optical sensor trigger and enter the input or symbol B1. And the third sensor is then set to capacitive sensor trigger and gets the input B2.
Wasn't there something about the lamps in the sensor housing?
Yes, thanks. I almost forgot. We'll also enter the respective input for the lamp objects so that B0, B1, and B2 light up when the sensor triggers. In the first sensor, B0. In the next sensor, B1. And in the last sensor, B2. Now to configure the cylinders. The drive to point skill is assigned to the cylinder rod. This is a drive with 2 positions and additionally a starting position. Here we need to enter a total of 4 symbols. 2 output symbols for extending and retracting, and 2 input symbols for the minimum and maximum end positions. For to max, I'll enter mm10_0 here. For to min, I'll enter mm10_1. For is at max, I'll enter b10_0 here. For is at min, I'll enter b10_1 here. For the stroke length, 45 millimeters is a suitable value. And for the duration of the movement, 0.2 seconds is appropriate.
We'll fast forward through the other 2 cylinders and then show the settings. What do you think, Nicholas?
Yes, we'll be right back.
Okay, here we are again with the settings for cylinder 2 on screen. And the settings for the last cylinder on the far right.
Are we finished now, or is there still a setting missing?
I think we're done with the skill settings now. All that's left is the C# script, which serves as a replacement for a PLC or a soft PLC. I've already prepared the script. We can insert it in the script settings. Here I can open the settings and create an empty script with this button, so the symbols are already automatically inserted as variables. If an editor path has been entered in the settings, it will open and we can copy and paste the program and save it. So that's it. Now we can start the simulation and check if we did everything correctly.
I'm excited to see this.
We start the simulation with this button and then can insert work pieces by clicking on the child objects of the creator. We see that there are problems with the metal cube. Let's take another look. I'll click on the cubes again. It doesn't get any better the second time around. I'm going to camera position 2. From here you can probably see it better. Yes, you can see that the side guard is a bit too long and is blocking the cube.
Yes, I see it. And what do we do now?
We need to shorten the side guard accordingly. Furthermore, we haven't removed the rear cube that we used to position the sensor. We'll do that now in Blender. First, we delete the cube by selecting it and pressing the delete key. Then we select the side guard and press S for scale and Y to constrain it to the Y-axis and shorten the object. Now we export it again via the plugin and switch back to the 3D Studio. With this reload button, we can load the file again and, lo and behold, the cube is gone and the rail is shortened. We'll go back into the simulation. And the problem seems to be fixed.
Very good. Mission accomplished.
Now we'll change one more thing, then we're done. Specifically, we'll set the creator to randomly generate cubes every second so we can stress test our sorting system. To do this, we'll change the skill properties of the creator. Here we'll enable continuous production and at this point, set the maximum number of children to 20. And here, 1 is set for the 1 second interval. That should work. By the way, we can change all of this during the simulation.
Now the production is running at full speed. Looks good.
Yes, it's quite impressive. Yes, Christine, thank you very much for the collaboration and patience. One more tip for the viewers. If you want to replicate the system, then watch the video for the necessary settings in Blender and the installation of the asset library and the plugin for the skills. You can find the videos and much more information on www.mhj-wiki.de.
Thanks, Nicholas. That was really fun. I'll also say goodbye to our viewers. If you liked the video, we'd appreciate a like and a subscription. Feel free to write in the comments what you particularly liked and if you'd like to see more videos in this style. Bye and see you next time.